Hi, everybody. So, just warm up for a minute. So, 5 p.m. Pacific Coast time, we'll be beginning. Einstein's biggest blunder was premature capitulation to the Hubble's explanation of the prevalent cosmological redshift of distant starlight and the overall increase with distance of that cosmological redshift as being evidence of ongoing cosmic expansion rather than past expansion that ended with the universe mature size and density, which would have aligned with Einstein's static. We're going to define Einstein static as the universe had a start in a hyperdense area, whether it's a singularity or we think a little bit bigger than that, maybe like Ramban, the size of a mustard seed, or it's pretty much the smallest thing that people could relate to that could grow quite a bit. And that it reached equilibrium, whatever the expansion force was. We hypothesized it had to do with electromagnetic radiation. See our electromagnetic radiation cosmic expansion hypothesis in Volume 2 of the Moshe Emissaries, Distant Starlight and the Age, Formation, and Structure of the Universe, based on spiral cosmological redshift hypothesis and model. Spiral stands for hyperdense protogalactic formation, preceded cosmic inflation expansion. The cosmological redshift attests to the lagging light of those that protogalactic formation as they moved away from the hyperdense area as the universe expanded. Actually, think of the raisin dough. Metric expansion caused them to distance, not necessarily that they were moving, but they were moving away from the center point, and we find no need to say flat on the surface the entire universe approximates the visible universe. So anyway, they were expanding, let's say, electromagnetic repulsion, like our electromagnetic repulsion hypothesis. Then the gravity. So eventually they got into equilibrium, and we were left at the end of cosmic inflation expansion with the universe at mature size and density relatively early in the formation of the universe. Now, everybody agrees that most stellar formation had to be relatively early in history, or we wouldn't see the relatively even distribution of stellar objects, at the outer reaches of the visible universe. How could we see them if they weren't there early on? Their light would not have reached us, especially if there's ongoing cosmic expansion. So everybody agrees. When I say everybody, I mean spiral cosmological redshift hypothesis and model and the standard cosmological model, LCDM, lambda, comma, dark matter. Everybody agrees the most distant visible stars were within 4 billion light years to get from the get-go, and that's there they would have remained. Could be quite a bit less than 4 billion light years, had it not been for the assumption of ongoing cosmic expansion or resumption of cosmic expansion, that's the Hubble expansion, over the course of an assumed 13 billion plus years. And therefore, instead of being 4 plus 13, maximum of 17 billion, now they're assumed to be, if LCDM, 46.5 billion light years, up to 46.5 billion light years from us, the edge of the visible universe that we are the approximate center of. If spiral, that's all there is. No dark energy required, no dark matter required, no flat on the surface required. The entire universe approximates the visible universe. The visible universe has a radius of a maximum of 4 billion light years that the most distant stellar objects were, that we can see were when their light departed them. Okay, so let's get back on track. So Einstein, okay, Einstein static. Okay, let's define that. Universe started, had a start, hyperdense. There could be other definitions to Einstein static, but that is how we are going to define it. And the universe expanded into somewhat equilibrium. He got into the cosmological constant to try to describe that. And that's a little bit beyond the purview of this, what exactly cosmological constant, what it was based on. But he basically thought that the universe was pretty much a stable size and density, a consistent density. So, but he abandoned that idea when he met Hubble. Hubble showed him, hey, look at all this cosmological redshift. Look at the increase with distance of the cosmological redshift. I think it's, he said he thought it was because of ongoing cosmic expansion. So why did Einstein agree and abandon his cosmological constant and idea that the universe was stable, not static? Static is often meant it was always like that. So it's Aristotle. That's kind of like a opiate of the masses, assuming that things always were as they are. Eternal universe, it fights against the laws of entropy, but it's very human nature to extrapolate. So if it's stable now, why may always be stable? If it's moving one way or the other, contracting, expanding, probably just keep doing that. But things are cyclical normally. But even cyclical, we could say we're on the first plateau of steady state oscillation. So even with oscillation, you can be held by oscillation, even under creation science, you can hold we're on the first plateau, steady state oscillation. Okay. So no problem with cyclical. If there was a stop, there was a first cycle. And okay, so here's why Einstein, based on the empirical observations, couldn't have it both ways. He couldn't have, what do I mean by that? He couldn't hold by static and that deep time dependent. Okay, so for some reason, Einstein assumed, whether he believed it or not, we're going to try to talk about if he really believed that, why he believed that, or if he didn't believe that, but he didn't have the guts or fortitude to say, hey, wait a minute, that a pure scientist doesn't care if the universe is 5,781 years old or 13.8 billion. Right now we're just focused on the two competing hypotheses, creation science, Perelman spiral, and standard cosmological model, LCDM. Either one's right or the other one's right. They're not both right. Okay, but SCM, LCDM is deep time dependent. Modern cosmology is premised, it's all built on an assumption of the Copernican principle. There may be another assumption or two built in, but that's one assumption of modern cosmology. And to say that over great distances, the universe, no matter from what vantage point you are, is pretty much the same distribution, matter and energy, that if you hold by, like I do, and like Einstein, of course, did, because he's pretty much who codified it with special relativity, the light speed limit is standard light speed. So if you don't have a light speed limit, there are all kinds of hypotheses you can come up with. But both models are assuming, as Einstein did, light speed limit of standard light speed. Now, if you hold light speed limit of standard light speed like I do and like Einstein did, and like those who hold by spiral and those who hold by SCM, LCDM do, then when you look at the cosmological redshift of distant starlight, if depending at where that begins, where that prevalent cosmological redshift begins, that's going to put a cap on the age of the universe. So things like neo-Darwin doctrine. So if you believe, and most scientists don't believe one way or the other, they have probabilities. This is the probability based on this assumption and giving that amount of context, that much weight. So if you hold that neo-Darwin, they go to theory, but it's a failed hypothesis morphed into a faith-based belief. So if you believe in neo-Darwin doctrine or Darwinism, I'm not sure, that may have been a different word, but maybe that is the word, but if you believe in evolution the Darwin way, we're not talking about microevolution within the base created kinds that the Talmud talks about and is perfectly compatible with what we know about biology and science. But if you hold that everything evolved from a common ancestor, random evolution over, it is deep time dependent. Nobody's going to say that you could get from some pond scum to everything, all the animal types we have now through random mutations and the neo-Darwin model without at least 300 million years of continuous life. So it's also has to be continuous life-sustaining environment for that to occur. So you need 300 million years. Neo-Darwin is deep time dependent. So if you hold by that, there are a lot of other cross-calibrated, so-called independent, but they all, you could say the same thing for creation science. We have, radiometric dating and plate tectonics. Once you take in all the science into account, we have multiple ways of independent dating to show that the thousands, not billions, age of the Earth and universe. So yeah, it's disputed. We know what the people who hold by billions, that's consensus. Anybody, credentialed scientist has had to study that and pass it. Very few, if any, credentialed scientists who still hold by deep time have actually studied the creation science. So a creation scientist against a consensus scientist, has a tremendous advantage because we understand both schools of thought, whereas most consensus scientists don't even know that they don't know that there is a competing science, and it's actually higher probability than the consensus. So anyway, if you assume, and you're going to accept that as a given, that the universe is over 300 million years old, in order for Darwin evolution to work, it's probably a lot older than that, then the nearest departure point of light reaching us here and now that's ever been subjected to cosmic expansion, it can't begin closer than a radius of 300 million light years. Orbital peculiarities, I'm not going to, so they're pretty immaterial. And when you get up there, you can just, figure that in. We don't really need, for this point, 300 million is plenty, because most people who hold by SCM, LCDM are going to admit that the prevalent cosmological redshift of distant starlight begins within the nearest objects that have ever been subjected to cosmic expansion are about 5 million light years away, which means that anything that puts a maximum year count, 5 million years, on the time elapsed subsequent to the end of cosmic expansion. Now, you could say, okay, so you could say, hey, we can't detect cosmic expansion in our local area. So therefore, cosmic expansion must have ended. So did it end? There's no cosmic expansion within, everybody agrees, within probably 5,000 light years. Show me some cosmic, some light coming from a stellar object within 5,000 light years. I don't think you can prove that or do it. Departure point. So why not? If there's really ongoing cosmic expansion, it should be pretty much throughout the universe. So they get into the escape mechanism of the consensus is gravitational bonding. It's gravitationally bound, so the gravitation within our galaxy or the local group, but but why would that gravitation be uniform? Would it be overcompensate, undercompensate in certain areas within 5,000 light years? And there should also be a checkerboard of the cosmic microwave background radiation, CMB. If that were true, should be a checkerboard of the way that cosmological redshift, from different distances and different areas, rather than near black body. There are issues with that, but that's the escape mechanism. I think it's pretty shabby. They say, and to compound that problem, you have Obler's paradox, where why isn't if the universe is really billions of years old, and we know that the stellar objects, most of them had to be there early on, or we wouldn't see, so far to the end of the visible universe. Couldn't be that far to the end because we wouldn't be there'd be nothing, radiating the light back toward us if it wasn't created early in history. So why isn't the whole night sky lit up like a cloud? How is there a crisp, dark night sky to see the individual objects? Ober's paradox, so that's another escape mechanism. Because cosmic expansion. So, because, this light from every object would have go in every direction and should light up the night sky. It's a little bit like the Milky Way, kind of cloudy there, but it'd be, much more intense. It'd be, probably like an overcast day when you try to look up at the night sky. If there was no cosmic expansion and the stellar objects have been there for, 13 billion years. So, okay. So we're going to make a given the nearest departure point, the nearest departure point of light that's ever been subjected to cosmic expansion is 5 million light years. That's going to be a max. Later we're going to see why it could be as few as 5,781. Just that by the time it becomes visibly red, and there are a few other variables, at least one other variable, it could be, so something 6,000 light years away could have been subject to cosmic expansion, but just a very small amount of cosmic expansion. And therefore, it never really made it to the red spectrum. It's between center yellow and, beginning of red. So just because something's not red yet doesn't mean it was never subjected to cosmic expansion. Okay, so Einstein, he either believed it, took it as a given, or decided to keep it to himself, that he didn't want to rock the boat that much, that the universe is over, say, 300 million years old. He could see with Hubble light arriving from stellar objects that were under 300 million light years away. And therefore, there must be ongoing cosmic expansion. Otherwise, there would be no cosmological redshift from any objects under 300 million light years away if the universe is at least 300 million years old. So there you have it, that the premature capitulation was, and he must have thought of this because he didn't want to give up, he wouldn't give up his ideas and what he thought everything added up with easily, unless he had some real observations. And these real observations that you really could say, if Hubble's right, if there's ongoing cosmic expansion, and if we do see cosmological redshift coming from objects under 300 million light years away, yeah, there's got to be ongoing cosmic expansion. Now, does that mean that the universe is at least 300 million years old? No, because it's an alternate explanation that cosmological redshift was from when the stellar objects were much closer. And even though by the end of cosmic inflation expansion, they ended up up to 4 billion light years away within a short period of time. Maybe it was like 400 million. I'm not sure. I mean, we can somewhere. I normally say 2 billion. It's safe to say by the end of a cosmic inflation expansion after protogalactic formation, so that light trails are being formed during cosmic expansion. They're metric expansion of space, cosmic expansion, perhaps due to electromagnetic radiation, like how you take two magnets and they're both positive, they push it away against each other until they're at a certain distance from each other. And then, so the same observations prevalent. Not only can we have the same exact observations of prevalent cosmological redshift of distant starlight and the overall increase of that cosmological redshift with distance, but we'd actually predict it. If we had hyperdense protogalactic formation prior to the cosmic expansion, we'd be predicting prevalent cosmological redshift of distant starlight and the overall increase of that cosmological redshift with distance. So we not only react to it like the standard consensus, but we actually would predict it. And again, in science, that's a tremendous advantage for our hypothesis against the competing LCDM hypothesis, because in our hypothesis, we would predict the cosmological redshift and the overall increase of that with distance versus the standard cosmological model that's reacting to it and trying to, come up with an excuse for it, like Hubble came up with one. And then even that excuse was, like we said, you need escape mechanism upon escape mechanism to try to explain away why Ober's paradox and explain away why no local light has been subjected to cosmological redshift when it arrives here. So under our model, there's a very good reason, because that the cosmic expansion ended shortly, relatively shortly after the start of the universe, after the stellar formation. So we have it, we're predicting that it's within four days, based on scriptural testimony, divided by 365 days in a year times 5,781 years to date. So that's the fraction. Within that fraction of history, the universe attained mature size and density. There was no more cosmic expansion. Therefore, every year that went by after that, the radius to the nearest departure point of light arriving here at Earth, the observation point, would increase 1 light year per year. So this year, it's at least 5,781 light years to the nearest departure point of any light arriving here and now that's ever been subjected, even ever so slightly, to cosmic expansion. Everybody agrees, both competing hypotheses agree that within 10, 20, 30, 40, certainly within 300 million, 100 million, 200 million light years, there's a lot of that light comes cosmologically redshifted. So if there's ongoing cosmic expansion, and if the universe, if you were assuming the universe is over 300 million years old, but if it's 6,000 years old, or 5 million years old, or 5,781 years old, there would not be cosmological redshift coming. There would be cosmological redshift of something over that amount, but not below it. So if the universe is 300 million years old, by that point, and if cosmic expansion ended early in history, like we find based on, we actually predict it, and it's self-evident that there is. So 300 million years from now, let's say this is year 6000. So let's say 300 million years from now, then there should be no cosmological redshift detectable here from any stellar object less than 300 million plus 6,000 light years distant. Okay, so in 10 million years from now, there'll be no cosmological redshift from anything within 10 million light years of us, just round it down to 10 million. Okay, so therefore, Einstein's biggest blunder was he capitulated to Hubble. So why did he do it? Because he either assumed or believed, which is always a mistake in science, he probably trusted in the other experts. He said, look, this guy's a biologist, this guy's a evolutionary, whatever, scientist. I'm not sure if they had him back then. This guy's a geologist, and he's saying this would take, and they kind of cross-calibrated because the geologist said the rock, which is ridiculous, took some 100 million years to form, or that it's that old because of radiometric dating, or because of extrapolating today's plate movement is, for example, just a rock formation. Even Tehachapi Torah Center, we had Isidore Osher, founder of Tehachapi Gem and Mineral Society. So anybody who really knows rocks knows there are a few variables: heat, time, and pressure. And in one of our hypotheses, which should be worth a Nobel, is the HTP hypothesis, stellar formation hypothesis. We show, and there are other scientists who know this, that stellar formation can be almost instantaneous depending on the heat, time, and pressure. So to rock formation. And the perfect example we give in Volume 1, the Moshe MS framework for understanding science and maximum available context, is diamond formation. Most people think those natural diamonds are millions of years old, and we happen to, and some of them may be associated with the asteroid impacts, I'm not sure. But in a factory with much less energy, heat and pressure, you can form an industrial diamond of the same chemical composition as a natural diamond in maybe minutes, maybe days, under much less force than an asteroid impact would have, obviously. So there's no way to know. Well, I think there is a way to know that most of those diamonds are either, if they were not here at the beginning, after creation week, and I think they were probably formed, a lot of them, during the asteroid impacts, but it could well be from creation week, especially if you find them on other planets. So if you find diamonds on other planets, why aren't there diamonds here? That would be from creation week. But again, heat, time, and pressure, there's no reason to require millions of billions of years. And radiometric dating, by the way, if anything, it attests to, of the two competing models, it pretty much falsifies the most reliable carbon dating methods, pretty much falsify the consensus, and only the last hypothesis standing is the creation science. For example, in the strata that they find dinosaur fossils associated with the asteroid impact, which consensus 66 million is one of them. And in the Moshe Emes, it happened during the Marble, 1656 on a Monday. It's about 4,200 years ago, around 4,124. 25. We're now at 5,781. Minus 1656 is 4,125. Comedy. So something, either some of the bones, some of the soft tissue, something in that strata, the coal deposits, that something there in that strata that was laid down during that impact when the dinosaurs, a lot of the fossils are from. I heard they were from the Marble. A lot of people do, during the Marble year. Carbon date. So that pretty much caps them at 60 or 70,000 years old max. Now that's a cap. In the books, we explain why they could date 20, 30, 40, 50, 60,000, because you'd have to take into account, when did the radiation build began. Certainly didn't begin before the physical universe, before the start of time, right? So the start of time was 5,781 years ago. Then that's when the radiation build could have began. But Victor Miller, 50 years ago, so, pointed out that circular reasoning of the consensus, lack of radioactive isotopes, deep time, lack of radioactive isotopes, which doesn't prove anything. It just proves you're relying on circular reasoning. So we hold that there's a much more protective atmosphere, stronger magnetic shield, thicker ozone layer, higher oxygen, and things are living with higher oxygen. There must have been lower radiation, or everything would have died. A lot of things would have died of radiation poisoning. So the dinosaurs grew pretty big. So low entropy, low radiation, high oxygen, very nutritious vegetation, nutrition. So they so that radiation build may not have began till, and then it wasn't all of a sudden radiation levels and isotope levels would be. It took a while to build, maybe over 1,000 years to reach the modern saturation levels. So that's why ages kept, and the entropy rate kept gradually increasing as the lifespans kept halving until they approximated the modern levels of where probably like 80 was a normal lifespan, and rarely over 120. Okay, or 80 was full, to be desired lifespan maybe. And there are plenty of times in history and places where it's not like medieval Europe, where it was unsanitary and people were dying off by 30 because of unsanitary conditions and war, whatever. I mean, in a lot of places, and in different, just look at Tanakh, at the ages of people during the one king of Egypt, 94-year reign, possibly. I think he started at age 6, so that's only 100 years. But there are plenty of Greek philosophers that lived 80 years, and many of the sages lived longer than that. So okay, so Einstein, he relied, he instead of relying on Torah's testimony, which has stood the test of time. I'm not sure, I don't know how much Torah he knew. There's a rumor that his last regret was not studying Talmud. No, maybe he meant Talmud Torah, because back then we say Talmud Torah Keneg Kulam doesn't necessarily mean only Gemara. So I don't know how much Chumash he learned, if he knew Rashi, if he knew Ramban. But his last regret, allegedly, was he didn't study enough Torah, or didn't know Torah, or wish he had studied Torah and Talmud. And Whether or not that was his last regret, it should have been. It should have been a very big regret of his entire life, because if he done so, and had he given even a fair amount of weight to Torah testimony, he would have, at the very least, not capitulated. He may have said, okay, I'll consider your model as a valid alternative, but look, based on what I know, it's possible the universe is 5,700 and however many years ago, like 60, like 20 or 30, whatever it was back then, when Einstein was alive and thrived as a scientist. And then he could have investigated more. He would have figured out the spiral, cosmological redshift hypothesis and model if he considered, or he should have figured it out. I mean, I'm assuming he, would think about things as much as I did. Maybe, God hid it from him and let it occur to me. But, by the way, this is pretty much shows what, from our vantage point, prevalent redshift of distant starlight, where that, how far it is to where that begins. And everything's not to scale, obviously, and that the entire universe approximates the visible universe. Now, also in here we have, this is Exhibit A. Exhibits B, C, and D show from any vantage point what you might see. And we have in here another Nobel-worthy concept, MVP hypothesis. So we have the most preferred view in the universe by far. We have a vastly preferred view over any distant vantage point. We also show that, every vantage point does have a local area where they're not going to see any cosmic expansion from, because the number of light years to the end of cosmic expansion, whether that's 5 million or like we determined highly more likely, and also from Torah testimony, we know 5,781, there's going to be no cosmological redshift from any object, from any viewpoint in the universe within 5,781 departure point from it. Okay, so Einstein had to capitulate because he threw his lot with deep time dependent doctrine. He assumed deep time, and therefore he was unable to, he ruled out what the strongest science, which you can't get here from there being the box, the deep time dependent box. Assuming that this is right, or the highest probability science, and we're confident it is, and nobody's proven up, people have tried to falsify it, but Sony had been getting, with every challenge, and it shows how obvious it is, and how the heavens attest to it. That, so you can't, if you're holding by deep time dependent, if that's a given for you, and that's the given in modern cosmology, and in a lot of other things too, if you hold by neo-Darwin evolution, deep time dependent. So if you're in that deep time dependent box, which is pretty much the consensus, then you can't, and if this is the actuality, pretty sure it is, from my perspective, it is, I know it is, based on Torah testimony and based on science, the probabilities are, stacked against deep time and for creation science. So that means that the actuality is outside the deep time dependent box. You can't get to the actuality from where you are if you're a scientist and you're doing what Einstein probably did, which was assume deep time. So I urge all people and all scientists especially, because that's your job, and to get off your blinders, drop your dogma, humble up, learn something new. You don't even know that you don't know that the strongest science is within creation science. Okay, Einstein. So why did Einstein capitulate to deep time? Okay, so he trusted the experts, even though they were self-fools, or intentional or not. Some of them maybe wanted to get away from, God and live in denial. Or maybe he thought, why should I believe in deep time dependent assumptions? But if you've seen what happens to some people who stop promoting, creation, intelligent design, or creation science, they can be ostracized, they can be blacklisted, they can be expelled. Ben Stein's Expelled is a movie about that. He, maybe wanted to fit in, peer pressure. He may have thought that people weren't ready for that. Sometimes, okay, if you're a quarterback, spiral, aside from stars preceding inflation, redshift attests to the light from those proto-galactic formation. But I used to like to play football, my brother, and spirals are cool. So if you're a quarterback, my brother was an excellent quarterback. I used to play quarterback a lot, but my favorite was defensive back and intercepting. But they had a nickname of Toast, Rabbi Huda Rosenbaum gave me, because I would get burnt sometimes if there's a good quarterback. But a lot of times, the quarterback would be the one to pay the price to eat crow. So anyway, you have to know your receiver when you're a quarterback. You could throw a really nice pass, but if you're throwing it too hard for the receiver, then it's probably going to be an incomplete. So you have to make sure he's even wider open than normal and throw it softer so he can handle the ball and, get a grasp on it before, the defenders come. So you have to know your audience. Einstein may have thought people are not ready for a scientist, and that he'll get ostracized and he won't do any good on the outside. He's better off, I'm not so sure he thought that. I think he didn't know enough Torah to have thought that. Oh, also to think like that, have that much confidence to even think about that, and then, bring it out later over and stamina. You have, it's not just for a short period of time. Over a long period of time, you have to be like Abraham. You have to be a very strong person to go against the tide, like Abraham did. Abraham Avery, one of the explanations is you pretty much had the whole world with Nimrod and the one world order, big government, no individual sanctity of, no individual freedom and liberty. The people were expendable. The government and were everybody had to conform. So Abraham had that confidence, and not that many people are that strong and can think, that smart and intelligent and aware like Abraham. And part of probably Abraham was having, Sarah, partner Sarah. So, say, I don't know probably to some degree true. Behind every great man is or person is a spouse. That is a great woman. So I think maybe Einstein. I don't know what his family situation was, but I'm thinking maybe he was having some shalom bias issues, and he wasn't consulting his wife, who may have given him enough strength to not capitulate and maybe bring out some ideas outside the box that would be met with ridicule. Now, he had plenty of that already, so maybe he just couldn't handle anymore. I really like, apparently, Hitler, Yamach Shemo, Einstein, your theories, you dumb cut Jew. Your theory is wrong. I have 50 credentials talking about. It has a higher, can either falsify it or has a higher probability explanation. So, that's one of the things I love about science is it's not majority rule. It's like whoever has the best hypothesis, has the strongest science. What's the strongest science? The highest probability explanation of the empirical observations, taken in maximum available context. So obviously, something Hubble have the highest probability explanation if you assume the Earth, the universe is billions of years old, and that so, and you assume the Copernican principle. But why assume that when the empirical observations will add up and cross-check with 5,781 years old, and you don't even need the fudge factor. You don't need the dark energy fudge factor because no ongoing cosmic expansion. You don't need the dark matter fudge factor because hyperdense protogalactic formation, rotation issue. You solve the Olbers paradox. You solve the why is there no local cosmic expansion. We know why. It doesn't begin before 5,781. And it's capped by about 5 million. Because, as we explained in Spiral. And CMB acts, CMB, cosmic inflation, that's, if you told by Torah explanation, cosmic inflation, CMB, cosmic microwave background radiation, perfect alignment, aligns as well or better than deep time does, I think better. Okay, so that's pretty much it. So Einstein capitulated because he decided that the universe is older than, millions or billions of years old. And he had to capitulate that it must be ongoing cosmic expansion if the universe really is, hundreds of millions or billions of years old. So that's why he had to capitulate. He made the mistake because there's no scientific reason to assume that the universe is more than 5,781 years old. That 5,781 can't be a viable alternate hypothesis. So we conclude the universe attained mature size and density very early. No subsequent cosmic expansion. Therefore, Einstein capitulated prematurely to Hubble. Explanation of cosmic expansion being due to ongoing cosmic expansion. Okay, so that's pretty much it. Anybody who wants to hang around, I'll try to just mention, I already mentioned a couple of them, the minimum of 6 Nobel's worth of scientific advancement within the spiral cosmological redshift hypothesis and model. So first of all, two have it on academia. Let's look at it there, the list of the 6. So the SPI of spiral, stars preceded inflation, so hyperdense protogalactic formation preceded cosmic inflation expansion. That's SPI. I for inflation, cosmic inflation expansion. P preceded S star stellar, so protogalactic, hyperdense protogalactic formation. So that's right there. That's hypothesis is worth at least 1 Nobel worth. RAL, the cosmological redshift test to the light of that protogalactic, that those stars did precede the cosmic inflation. So the RAL, that the redshift attests to the SPI, is 1. So up to 2 Nobel's worth of concepts in the spiral, also known as distant starlight and the age, formation, and structure of the universe, or also known as distant starlight and Tara, also known as creation science and Big Bang cosmology. Okay, 3, cosmological blue shift offset. Okay, so if hyperdense protogalactic formation and during the cosmic expansion of the fabric of space, not just was the universe expanding on a macro level, but the individual hyperdense galaxies were also expanding. So the near side of galaxies, as they expanded away, the near side were moving away from this back toward us. So that when something moves toward us, or else being equal, that light, the spectrum gets shortened, and that causes blue shift. What was moving, and the far side, which is of something moving away, which is getting redshifted, the frequency is lengthening, are being the redshift is being supplemented by the expansion of the individual galaxy. So if the galaxy was already mature size and density when it was moving away from us, then the whole thing would have pretty much uniform cosmological redshift. But because of the galaxy itself was expanding, therefore the near side, the more distant, further it is from center and heading back toward us, the more redshift. Therefore, you'll see on a spiral galaxy, you see a lot, some special, within a certain amount where it's not overwhelmed by the cosmological redshift. Well, don't forget, with distance, the greater the distance, the greater the cumulative amount of cosmic expansion it's being subjected to. So the near side of galaxies that are over 5,781 light years away, and there aren't too many in there, if any, and less than probably like 100 million, you'll notice a lot of times some blue shift on the near side of the like in a spiral galaxy, on the arms of the spirals that are near side. And a lot of times people don't even think of that, near side, far side, why should there be any difference? But yeah, look for that. Scientists out there who are good at astronomy and have the equipment study compare the near side to the far side of galaxies and look for that cosmological blue shift offset hypothesis, explaining to you, what you're seeing with the blue shift. I have a feeling the Andromeda galaxy may not be really moving toward us. That's just residue from when it, we're seeing it now from when it was 5,781 light years away, when it was closer and a little bit more dense during the cosmic inflation expansion epoch. Oh, so yeah, and we're actually seeing all galaxies that are over the distance between, where the nearest departure point of light that was ever subjected to cosmic expansion. So anything beyond that, we're actually seeing from right here. So all the stars here, we're seeing them from when they were over here. Now, if this is a maximum of 4 billion, this is, let's say, 6,000 or 5 million, start at 5 million, but work your way down. Eventually, you'll probably figure out that it's 5,781 to date and add one a year. But all these stars here we're seeing from when they were pretty much this distance from us. Let that sink in for a minute. Now, okay, so if this is 4 billion to the edge of the visible universe, and it could be 2 billion, it could be 400 million. I have a feeling it's more than 400 million, but I haven't ruled that out yet. But I'm just assuming about 2 billion. 4 billion max, because no cosmic expansion after very relatively early in history. So, we're seeing objects from when they're 4 billion light years closer. How could that be? Well, if you hold by SCM, LCDM, you actually hold that you can see stellar objects. So you hold this from here to here is 46.5 billion. It's just 46 point. Again, is just think of this as a sphere of the visible universe, not the shape that it's in because of the book cover. 46.5 billion if you hold by LCDM. That's where the stellar objects are now that we're seeing here. They did not depart for more than 4 billion light years away. You hold 13, a little bit over 13 billion years ago, and because of ongoing cosmic expansion, instead of that being 13 billion, now it's 46.5. But either way, these stars were, let's say that was 4 billion here, if that's 46.5 billion. So 46.5 billion minus 4 billion, you actually hold that the most distant stellar objects that we see here and now, the light departed them when they were 42.5 billion light years closer. So you really can't say anything that, that can't be valid, because if 4 billion light years closer can't be valid, then 42.5 billion can't be valid for sure. In addition to deep time being a vastly greater claim than creation science because of the law of entropy and the law of science, also known as the law of entropy. All right, very good. So far we have SPI or spiral 1, Noble Worth, RAL of spiral 2, spirals cosmological blue shift offset 3. Now, because cosmic expansion ended and we started with hyperdense protogalactic formation, we would actually predict that at the center of every galaxy used to be hyperdense. So when we see the appearance of black holes at galactic centers, what are we seeing? We're not seeing it now. We're seeing it from when the light departed it, which was a long time ago, early on. So we're seeing it from when it was hyperdense, or after it was hyperdense. A lot of them when they're still somewhat hyperdense, or going from hyperdense to mature size and density early on in history. So all the matter in every galaxy started near the center of it. So when you see a black hole, that's what you're seeing. The center is no longer hyperdense, and hasn't been for a long time. All the material in a galaxy, most of it, unless it came from a different galaxy, started by the center of it. So when we see a black hole at a galactic center, we have that hypothesis, and it's called black hole illusion resolution. So that's Nobel concept. That's the fourth, number 4. Nobel-worthy concept number 4 in spiral cosmological redshift hypothesis is black hole, HOLE, illusion resolution. So black holes are no longer hyperdense. So there's no singularity issues. So that may solve the problem with gravity and quantum gravity, quantum mechanics, because there are no more singularities. And even the first singularity, like we mentioned, that started the Big Bang, that it may not have been a singularity. Why not say the Ramban? God, when he spoke in 10 utterances, made all the matter on the beginning of day one, the start of time with the beginning of the universe. Why start with a singularity? Why not start with, you have a supernatural God, which is required because the law of science known as the conservation of energy. Check out book number 1, the Moshe MS Framework for Understanding Science. God started with, like Ramban said, hyperdense, yes. Singularity, if it resolves the science, so then probably wasn't a singularity, probably was maybe a mustard seed size, if that, that way it's less of a scientific, there are fewer issues. It's, the laws of science don't break down, laws of physics don't break down. And so if you can do it with all the laws of physics being in place from the get-go, do it that way. Why do it create a less parsimonious approach when it all fits very in a very parsimonious thing? It's not a question of if God did it. Obviously, that anything and everything that exists physically, even the laws of nature, attest to God. God must have done it, or there wouldn't be anything. The universe had a start, and because of the law of entropy, science, had a start. If you're going to argue it didn't have a start, you're fighting science, you're fighting entropy. So, yes, a black hole illusion resolution solves a lot more than explaining to us what we're looking at when we're looking at a black hole. It cleans up a lot of the crisis in cosmology, and it helps solve the theory of everything because, there is no contradiction between quantum mechanics and gravity if you don't have the, where does that really happen, that conflict? And it might happen only in theory, and the theory may have never happened if you don't have black holes anymore, don't have any more hyperdense black holes, and you didn't start at a singularity, you started at a mustard seed size, like Ramban 1,000 years ago. Okay. All right, anyway, we show in scripture how spiral is, very consistent with not just science, but with scriptural testimony. For example, day 4, the name of God, the Shin, Dalet, and Yud. We have it on the back of our mezuzah, on our doorposts, and Pirkei de Rabbi Eliezer, and also in Talmud. It's not just Pirkei. Explains that means Sha'amadai, that Hashem, the one designer creator, aka God of Abraham, supernatural, because you don't get something from nothing, just like described by Moses, said enough. Shin Sha'amar, die, enough. So cosmic expansion, day 4 going on, enough. the gravity and electromagnetic radiation or whatever else the expansion force was, if it wasn't electromagnetic radiation, got to equilibrium, and the universe was mature size and density by the end of day 4. Plenty of time, for day 5, fish, birds, dinosaurs, Taninium, Gadolium. How we do? Check out volume 1. And day 6, animals, and then starting the last 12 hours, we have an hour by hour from the formation of Adam in full stature until the onset of Shabbos, Sabbath. All right, I hope you enjoyed. So Einstein's biggest blunder due to premature capitulation. Had he had assigned, if he had known Torah and given it fair weight, he would not have capitulated, because it's fair to say he at least thought of as much, as I do. And he, when he realized, hey, it doesn't work with deep time, so he stopped thinking about it. I kept going. And because I'm outside of the box, all of these, a lot of easy pickings, because it's like having a treasure map and everybody has a wrong map, and they're all looking over there, and over here, all the gold's hiding in plain sight. Okay, so anyway, so in our hypothesis here, we're up to the 4 nobles worth. Black hole illusion resolution, we actually don't react, just like with the cosmological redshift, we actually predict it rather than react to it. With the cosmological blue shift, we could predict it, why we see blue shift in galaxies up to about 100 million, and after that it gets overwhelmed by the redshift. So black holes at galactic centers, the appearance of them, not that they're hyperdense anymore, we actually would predict that, because we said hyperdense protogalactic formation. So those galaxies started hyperdense. So it would appear that the black holes would be what might appear at galactic centers. So we'd actually predict what we're looking at, just that because we understand it a different way because of our perspective from spiral, rather than the current where they assume stellar formation, the Big Bang, matter scattered out, and then through accretion over a pretty long period of time, not that long, stellar formation relatively. Okay, and then some just started, gravitation pulling stuff in until you got to a singularity or something. So, that's not happening. That didn't happen, and it's not happening. So once you understand the science and the probabilities, safe to say, and especially if you give proper weight to Torah testimony. Okay, so we're up to 4 nobles. With the 2 others, I mentioned them during the presentation. MVP hypothesis. We have the most valuable view in the universe. So whoever thinks that over long distances, every viewpoint is pretty much the same, wrong. We have a vastly superior favorite view in the universe. You can only see a small fraction of what we see in any distant viewpoint. Certainly once you go out over probably 6,000 or 10,000 or 100,000 light years, your view is going to be very restricted. And HTP, stellar formation hypothesis. I also have a couple in here. I don't think they give Nobels for it, but lunar formation hypothesis that actually explains the cause and effect for the original single continent on Earth. So, certainly if Nobels were just for scientific advancement, period, that'd be worth that'd be Nobel number 7. And then that's called draw play. And then SNAP hypothesis, the formation of the Earth, early formation, which may start as early as day 1. SNAP is in there. I don't think they have a Nobel for that. Although you could argue that's a little bit astrophysics, but I'm not sure. And also that could SNAP, although I just, talk about the Earth, being in the snap, but our solar system could have also been a lot of it, and that could explain, why we have gas on that planet that they found some gas on. Okay, recently. All right, so I hope you enjoyed it. We've been talking a long time. Now we're not that long. An hour and 15, hour and 20 minutes. So again, want to thank my wife, my parents, my siblings, my children, my friends, my rebbeim, my teachers, my fellow students, my friends, my good neighbors, participants, people Torah attached to the Torah Center and Friends study group more recently, but the yeshivas I've gone to, Rabbi Rachamim Pauli, who knows a lot more astronomy than I do, very physics background, physics royalty. I didn't pronounce it right in the intro to this. Physics royalty, royal, like a royal king, royalty. His great uncle being Wolfgang Pauli, who is a big aide to Einstein. So in some ways, Wolfgang Pauli and maybe even Einstein's wife may have been, a better scientist than him. But it took a teamwork. So Baruch Hashem, I think we've really advanced the science. I've mentioned 6 Nobel's worth, 2 hypotheses that might be Nobel worth. In let's see, what's I have here? Oh, I want to thank John Hotnet, Gideon Hotnet, John Gideon. Forgot exactly. Anyway, he's a credentialed astrophysicist who gave me early peer review. So got me past, pointed me in the right direction very early on in the formation of spiral cosmological redshift hypothesis and model. He said, you have to account for the cosmological redshift, the overall increase with distance, and I've done that. Pretty much, it's also the holy grail of young Earth creation. So not only do we show how and why light speeds limited to standard light speed can align with Torah testimony and creation science, but it attests to it and it falsifies for all practical intents and purposes based on the laws of probability all deep time dependent scientific hypotheses and assumptions. So that means, again, look at spiral versus SCM. So basically SCM, LCDM, consensus cosmology is falsified for all, based on probability, still a chance if you believe in, playing poker in a fair game and you can get 10 straight flushes in a row, that's much more likely than this being wrong. And okay. Okay. Good. Okay, spiral. 6 of those. Okay, so then we also have, so volume 1, the Moshe Emma series, is 6 principles for the alignment of Torah and science. Volume 2, spiral, with 6 Nobel's worth, plus 2, about 8 Nobel's worth, although I don't think you can get a Nobel for 2 of them. The lunar formation, Earth formation hypotheses, snap and draw play. And then volume 3 is the alignment of ancient civilization with Torah testimony. So we find out, when did the dinosaurs live? When was Adam formed? We coexisted. Dinosaurs were not on the passenger list of the Ark, the Taninim Gedolim, for various reasons it talks about in the Talmud. We reference that in there, volume 3. The Ice Ages explain. We have probably about 6, probably more in that book of great insight than we have in, even if this turns out to be right, which would, be the biggest thing that happened to science in the past, maybe in human history, I'm not sure. But yeah, we have even more on the Terra Discovery chronology, where the timing of the ice ages, Göbekli Tepe, Ur, the formation of Ur, when Egypt was founded. I mentioned, how man and dino coexisted. When did the continents break up? It was the original single continent formed on day 3, Dirac hypothesis, until the start of the Marble in 1656. And the Marble impacts year, when you had the asteroid impacts, 1 or 2, probably 2, see Jack Haneke and 3 peer-reviewed articles in the Terra journal that I mentioned in the intro video. What's the cause and effect for the onset of the ice ages? So you have hundreds of millions of years that are accounted for by a few years. And by the end of the ice ages, it's only about 340 years to the end of the ice ages from the breakup of the original single continent. We get into plate tectonics and radiometric dating and volume 1. Okay, so the ice ages, Göbekli Tepe, founded by Noah and family and sons. Who was Sargon I? We identify him in the Chumash. The famous Akkadian king. Who is Eliezer? Sargon I. Who is Sargon? Canaan, son of Ham. Okay. Eliezer Og. Who is Og? Canaan, Eliezer. Okay, so we tie them in. Works out really well. Everything adds up. The 430-year span with the covenant between the pots. We know, so it was not, something happened to Abraham was 70, Rashi tells us, but I don't think Rashi holds by it, because Rashi teaches other things, which means that Abraham was not 70 at the Brisbane of Sarim, but something happened. Rashi quotes somebody who, and they may have known something had to do with 70, because 430 years from when Abraham was 70, we had the Exodus. Because when Abraham was 30 years after Abraham was 70, at 100 he had Isaac, and Isaac was born 400 years before the Exodus. So what happened? So we solved that in Abraham into the Exodus. The catalyst for the Brisbane of Sarim was when Abraham was 70, about 14 years before the actual Brisbane of Sarim, the covenant between the pots. 52-year Persian span. When was the Exodus? Pepe 2. The riddle of the Exodus has some of the, a lot of people have bits and pieces, we put it all together. Pepe 2 was not the king Pharaoh of the Exodus, but shortly before he was the king whose daughter adopted Moshe, one of his daughters. Okay. And yeah, the Al Amana letters, you had that tied in, really well. So we find, this is, I don't think anybody else has this, Ramses II is the father-in-law of Solomon and is Shishak. And why we explain why he became known as Shishak. Has to do with the 400-year stele, which started not at the beginning of the New Kingdom, but the beginning of the 108-year Hyksos period. 52-year span. See Perlman's Chazal-based 52-year span. And the 208-year Persian span between Cyrus' proclamation and Alexander begins to beat Persia at the River Granicus. We show why that's 52 years from 3390, 70 years after Nebuchadnezzar's initial occupation in 33,320 on a Monday until 18 years from that until 3338, year 410 from year 4 of King Solomon, 410 Holy Temple 1. So 70 minus 18 from 3320 to 3338. So 18 plus 52 is 70. So 52 years from the end of Holy Temple 1 until Cyrus' proclamation, which was 1 year after the fall of Babylonia to Cyrus, who at that point was still deferred to some degree to his uncle, or cousin, uncle, his mother's brother, Darius the Mede. And, okay, so we also show that Darius the Persian, year 2, when we resumed due to prophecy, even without permission from Persia, Holy Temple 2, after it had been paused, we show that was because of Cambyses II, during the lifetime of when Cyrus was still alive, his father. So we find that Darius the Persian is not Artaxerxes, the son of Esther and Xerxes. No, he's Darius I the Great, son of Histapes. So that is Histapes the Persian. So Darius the Persian, year 2, is Darius I, the grandfather of Artaxerxes, the son of. So Darius the Persian is the father of Xerxes, who's the father of Artaxerxes and Darius Artaxerxes, who started in 3,408, probably, not 3,407. But yeah, we're okay with being, we're just trying to give the approximate on some of these. Sometimes we're off by a year because of the various reasons. Okay, so I hope you enjoyed it. Check out our other, please subscribe, please share. Follow us on Twitter, Facebook. Subscribe here on YouTube. We're going to go for the whole hour and 30 minutes, 90 minutes. Academia, ResearchGate, Quora. I answer a lot of questions in Quora. Often I'll post them onto Twitter. Okay. Any questions? Type in or email. Get me your questions here on Quora. Follow us, subscribe on YouTube. Check out our other. Please like and share. And it's important that we realize, recognize, and act with gratitude and try to live responsibly. Each of us is created, endowed with sanctity. So that's part of the whole point of this Torah and Science alignment, to show that, Moses was right to begin with. Everybody's special. We have to all treat each other with respect. We all have responsibility. Anywhere from 7 basic universal covenants, Noahide covenants, until 613. Obviously, not everybody's a Kohen Gadol, but we all have our responsibility and have to try our best to live up to our responsibility. And God is the sovereign of the universe and our Father. So, we have to treat others with respect and try to leave everything better for the next generation. Okay. Don't forget, science is cumulative. Modern science is cumulative. That means they're building on the old assumption premise, so it's probability based. If you have a faulty premise, you're probably so far off from the actuality now that you can't even see, that's, probably drowning in confirmation bias. So don't forget, the beginning of wisdom is awareness of Hashem, God, and God who alone has 100% perspective, he told us a lot, basically gave us the owner's manual. The chart is like the owner's manual. So you don't need to do things by guesswork. Use the owner's manual. Okay. Everybody have a good year. Be inscribed, and so hopefully we can continue working toward peace and prosperity and liberty for the. Okay. Thank you for listening this long if you're still with me.